So let us start with the first question of today's contest. So our first question was fashionable array, and problem statement asked us that the minimum we were given an array of n elements, and we were asked to uh, determine how many deletions we have to do in the array so that the minimum element of a and the maximum element of a, the sum of minimum element and maximum element is divisible by 2. All right. So basically, we have two cases to make this divisible by 2. First, that the minimum is even and the maximum is also even, and minimum is odd and the maximum is also odd. And if one is odd and one is even, then we have to delete the maximum element or the minimum element some number of times, so that we get both the elements as odd or even, right? And then we will get the sum as divisible by 2. So let's check the code. There is not too much to make you understand. So first of all, what we did was took the inputs and then sorted the array. Now I made two pointers L0 and Rn minus 1. So first of all, we checked if sum of the minimum element and maximum element is divisible by 2, then we have output 0, as the minimum number of operations required is 0 in that case. And if one of them is like if the combination is odd even or even odd, then we have checked if move the L pointer from 0 to n minus 1, and we have checked if it changes from odd or its parity changes. Then we count how many steps we took, and that we have taken as the operations. Again, we have also checked from R, and we have decreased it until its parity changes, and counted the number of operations, and minimum of both of them will be our answer. So, is there any doubt in this approach or solution? Is the solution clear to everyone? All right. So the next question was down with brackets. So we had a bracket. We were given a bracket sequence which was initially balanced, and we uh, could do the operation like removing a opening bracket and a closing bracket, such that the bracket sequence becomes unbalanced. Now you know what a balanced sequence and unbalanced sequence is, right? So suppose we have same number of opening brackets and same number of closing bracket, like same number of closing brackets before after the number of opening brackets, then it is called balance. Suppose like this is a balance sequence, but if we are given a sequence something like this, then it is unbalanced, because after one closing bracket we have two open after one opening bracket we have two closing brackets. Also, like suppose we have this sequence, uh, yeah, this one. Like in this case, if we have this one is balanced. If we had one more, like suppose we have two opening brackets and after that we have three closing brackets, then it will be unbalanced. This is also an unbalanced sequence. If we make it like this, so it will be an unbalanced sequence. So we were given a balanced sequence, and we have to make it unbalanced by removing one open bracket and one closing bracket. All right. And it was given that we have to remove only one opening and one closing bracket. So one thing you can do is you can see this sequence like you have seen in the first test case. If we have the starting brackets all continuous and then all continuous closing brackets, then the answer will always be no. You may check it like by doing any number of operations and all the combinations. You will get the balance sequence every time. But suppose if you are having sequence like this, where you are having uh, two opening brackets, two closing brackets, and again another sequence of closing and opening brackets, then you can make it unbalanced by doing some operations. So this was the thing you can check, or I have done an approach where I have just checked by removing the first bracket and the last bracket. So if after removing the first and last brackets, your answer was your sequence was balanced, then the answer would be no, or else it would be yes. So what I did was taken the input. If the length of the sequence was 2, then the answer will be no, because empty sequence was also balanced. Now I have checked from I equals to 1 to n minus 2. Like I have checked only for the yes. So I have only checked for the first sequence and the first from the second index till the second last index. So if it is balanced, then you may say the answer is no. If it is unbalanced, then the answer is yes. Is there any doubt in this question? And also this code was written to check if the sequence is balanced or not. Like when we have a opening bracket, we have increased the count, and when we are encountering a closing bracket, we are decreasing the count. If any moment of time we have more number of closing brackets, then the count will be negative, and we say the sequence is unbalanced. So I guess there is no doubt with this question. So now Hirak will proceed with the next question. Thank you.
Hello, is my screen visible? Hello.
Yes.
Okay. So, like what the question she says. So it's like a the game Flappy Bird. Like you are given uh, n obstacles. Obstacles are represented by two number L and R, and your drone is start at height 0. So and you are given another vector D where it represents if D equal 1, then the drone go one like one block above. And if D is 0, then it will stay at the same level. And what the question asks, like the D array has some element missing, like which were given as -1. So we need to find the values of those missing elements such that the drone can go past through every obstacles when the drone will pass through obstacles if the current height of the drone is less than ri for the ith obstacles and is greater than li, it's greater than equal, which is given in this question. And initially the height of the drone was 0. So what we can do, so we are given the array, right? So we can for the values which are present in D, we can track the path of the drone. If D is 1, then we go up. If D like if D is 1, then the drone will go up, and if D is 0, it will stay at the same level. So okay, and when D is -1, now we have to find what will be the best for us to keep it 0 or replace the value with 1, so that the drone is able to pass all the obstacles. So first, like let's suppose these are the obstacles. Like I'm not representing this by number. Like assume this through this image. So this is the obstacle. Begin begin like this. Okay, like these are at same height. These and these are same height. These and these are at same height. This so if the drone starts here, right? So if first value of D is 0, then it will stay at the same level and it will pass through this obstacle, because in this condition height will be less than equal to height will be greater than equal to lower side of the obstacles, right? And if D is 1, then we can add plus 1 and we'll proceed like this. Okay, now when we encounter when we encounter D of I equal -1, now what should we do? So if we initially ignore all the missing elements, like only consider d of I equal 1, and we will move the drone like this. Suppose current value is 1, so we will go up, and then 0, So we'll go at the same level. Again 0. Suppose this is -1. No worries, we'll go at the same level. Okay. Then there is suppose +1. So we'll go there. Then again 0. Then +1, like again +1, like this. Okay. And there are some missing. There are some missing number. Suppose -1. Now we'll not consider this, like replace this value till now. We'll assume this value as 0. Now the question is, how do we like replace this -1 so that the drone will go like through the path. So for if all di is 0, like if we replace all di with 0, where like previously di was -1, like we'll replace all this -1 with 0. Okay. All this -1 with 0, then that will like this will have the track of the path. Now I can say, like suppose this value is 10 and height is 8. So before this point we can replace only 2 minus 1 with 1. Otherwise if we replace 3 minus 1 with 1, like 3 minus 1 with 1, then this height will be 11, which will rest with this border. So we can like use only 2 minus 1 before this point. Similarly for every like obstacles, we'll see, we'll like first check what is the current height of the drone. If like all di is all like di -1 or -1, when all -1 are replaced with 0, what is the height of this drone and what is the maximum height it can go. So this difference will be the maximum number of -1 which we can replace with +1, right? So what we'll do, for every ri, we'll see what is the what is how many -1 before ith obstacle can be replaced such that the drone will pass. Okay. So like that's the main logic. So if we calculate for every ith obstacle, how many -1 before this we can replace with I, then uh, replace with I and check, and that's the number of -1 we will be replacing with I. So let's go through the code. Okay. So this is all the input part. This is the input part. Then this is like this is the current height of the uh, current height of the drone, like when all -1 are 0. This is basically a prefix sum. Like if di is 1, then the drone will go one level up. Otherwise, it will remain at the same level. And this is the uh, possible is the like possible of I is equal to the number of -1 that can be replaced with +1, so that it will pass ith obstacle. Okay. And this is the formula to calculate this. This is the upper bound of the obstacles minus current position of the uh, what do you say, the drone. So this will give like how many minus 1 can be replaced with plus 1. Now what this line now what this line says, I am like, let's suppose for any j index, let's suppose we can like use only 2, we can replace only 2 minus 1 with 1, okay. And for I index we can replace 3 minus 1 with 1, and I is less than j. So if we like replace 3 minus 1 with 1, then this condition will not gonna satisfy. So possible of what will be possible of I? Possible of I will be minimum of possible of I, comma, possible of I plus 1, right? Like if to cross like this obstacle, we can like only replace 2 minus 1 with 1, okay. And crossing a obstacle before that, which like for which we can replace only two only we can replace up until 3 obstacles. So if we like replace 3, then there the drone will be gonna crash with the upper obstacles. So we'll have to like for this I also the value will be not 3, it will be 2. So this line, check this, possible of I equal minimum of possible of I comma I plus 1, okay. Now for this like this line, check if the starting value is minus possible of 0. Like possible will be I am taking minimum from the end, so it will be like an increasing array, right? So if the first value is like less than 0, which what that means what, like, if this is the like obstacles and the drone is here something, then only this value will be negative, right? And up till now we are not replacing minus 1 with 1, okay. So there is no way to like take this down. So answer will be no for this case. Now come the main part, like I have declared two variables. This is the current height of the drone and this is the number of minus 1 that are replaced with 1. So like if di equal 1, then like increase the height. If di is minus 1, and check if like a number of use like number of minus 1 that are replaced by 1 is less than possible of I, then we can like use the minus 1 as 1. Like it is always like beneficial for us to take the drone upper full such that this will like, lower than the uh, possible value for current obstacle. So if use is less than possible of I, then I am increasing, like I replace 1 minus 1 with plus 1, then height will be like increased by 1. Then for that di will be 1, right? Like initially it was minus 1. If all the conditions are true, then I am replacing it with plus 1. Otherwise di will be 0. Now check if the current height is less than L, or like less than L or greater than R, then the answer is no. Otherwise you can like simply replace like print the vector. Is this clear, or like do you have any doubt at all? Okay, if this is like you don't have any doubt, then we'll move to the next question. So this question is like, if you read this question, like there is a there are n checkpoint on and every checkpoint, I checkpoint contains bi batteries, and initially like the robot started first checkpoint with no batteries. Like you have zero batteries and you are at the first checkpoint, and you must reach the nth checkpoint, okay. And there are m one way passes between the checkpoints. Like from one checkpoint to another checkpoint, there was a like m path from like not from one to like, there are m path connecting any two checkpoints, okay. Like this path you can enter through one checkpoint and you will exit through another. This is the I, the process allows movement from SI point to TI point. Like using the passes, you will always go to the like some next uh, uh, checkpoint, not like any previous checkpoint. This is given in the question. And additionally, you can able to use the uh, ith passes only if the number of batteries you collected through the pass point you have passed is greater than equal to wi, which will be given for, it will be different for every passage. Okay, so now what the question asks, like, and in every checkpoint you can pick any number of batteries present in the checkpoint. Like you can pick 0 to like b of I batteries from the ith checkpoint. Okay, now the question is find the minimum number of batteries that the robot need to pick so that he can like go from 0 to he can go from first point to nth point. Okay, now if we like analyze this test case. Okay, first, like these are the uh, batteries at and like every checkpoint. So now the first, what the first passes you can go from 1 to 2, and for that you have to you have to at least have one batteries at like checkpoint 1. Then you can go from 2 to 3, 2 to 3 using only one checkpoint. Using for that you have to have at least one like battery, and then you can also go from 1 to 3 directly. For that you have to like have at least two batteries. Okay, and like here you have two batteries, here you have you can pick up to zero batteries, here also you can pick up to zero batteries. So there are okay. And like it is given that uh, it always carries all the previously collected batteries. Like batteries will not be like used in the passage, it will uh, like it will still remain with you. Like suppose one passage required x batteries, so like number of batteries will not be reduced to x. Okay, uh, so from in this discussion, like there is two parts. Like first one is go through 1 to 2, then 2 to 3. Like for that, you if you pick one battery at checkpoint 1, then you can go through this part, and also you can go through this part. So using this part, the answer will be 1. Okay, if we pick up two batteries, pick 2, then you can go through this part and reach 3. So the answer through this will be 2. So what will be the minimum? Output the minimum number of batteries that you have to pick. So this will be the correct answer, right? So let's see for the last case. From 1 to 2, need one battery. From 1 to 3, we need three batteries. Then from 2 to 3, we need 10. MSD से पता नहीं, देखना पड़ेगा. And then from 3 to 4, you will gonna have need 5 batteries here. You can pick up to 3 batteries here, 10 batteries here, and there. So what will be the like path which will give us the minimum? If we go through this path, okay, so we can pick 3 batteries here, and we can come to this point. Now we have like 3 batteries, and we cannot pick any batteries from here, so we cannot go through this path. So this option will not be uh, this path will not like we cannot use this path to go to n, right? So uh, like let's check this path. If we pick one battery here, then we can go through this path. Okay, Now we have one batteries and we can pick up to 10, and we need 5 batteries to 10 batteries to go this path. So we have to pick 9 more. So here one, here 1 plus 9. That we can go here. Then we need 5 batteries, but we have 10, so we can clearly go. So answer through this part will be 10. So if we see this, we can use Dijkstra algorithm for the question, like Dijkstra's algorithm. Like suppose you are at this node and you have like you have already picked this amount of batteries, and like and you like W is the maximum weight of an edge you have already uh, like from like between all the edges you are already passed to reach that point. W is the maximum of all the wedges, and battery is the like sum of all the batteries like you have picked. Like if a node has like bi equal 10, you like pick 10 batteries there. Like like suppose this node has this some x, this node has 10 batteries, and from this from the go you need one, but you here you also have picked like all 10 batteries. Okay, like we are supposing this, then the answer will be the like minimum the maximum weight of an h like in any part from 1 to n. Suppose like there is like many parts from 1 to n. Okay, so like two part, right? So the answer will be a maximum of like if we're using this part, the maximum answer will be 3. Then if we're using this part, the maximum will be 6. So answer is the minimum of this maximum, right? So uh, so like for Dijkstra we maintain a priority queue, right? So this priority queue will have three variable. First one is the maximum weight of an edge you have already like from all the edges you have already passes. W is the maximum weight between any edge. Then this is the amount of battery you have already picked, and this is the value of that node. Like this means like to reach V, the maximum weight you have traversed is W, and the amount of battery you have is this BAT. Then then the answer for B will be W, right? So if we like uh, gone through the algorithm, and when we reach the end like the last node connect checkpoint, then the answer will be this, right? So if we uh, like go uh, so like how are we gonna like use the like we'll initialize the priority queue with three variable, and then uh, 0 comma 0 comma 1. So this is for the first index. To reach first index you have to like cross through a like 0 h, so this will be 0, and till now you like need like you don't have to pick any batteries, so this will be also 0. Now while this PQ is not empty, right? So we'll like extract all the value W comma, and this is battery, and this is current node from the PQ, and like we'll like delete that from the PQ. Okay, then like we'll be maintaining another vector like I named it DP, but it's not DP exactly. So DP from 1 to n, and initially all values is -1. So now DP means like answer for V node. Okay, dp of v will be w, right? And when, if v equal n, then like answer, like return, we already get the answer, right? This will be the answer. And otherwise we'll go to all the, like uh, from all the adjacent, like all the edge from v, like for each u comma w in adjacency list of v. If uh, now, this is the battery we have till now, plus the battery at that this v node, b of v is greater than equal to this w, right? This w, not that, this w. Then we can pass, like suppose this is v, and this has, like suppose uh, this requires 10 battery to pass through this edge, and this v has 5 of its own, and to reach, on reaching v we already collect 5, then this plus this is greater than this, so we can go through this edge. If this edge has 11, then we cannot go through this edge, okay? And if this is 9, then we can go through this edge. So if this condition is satisfied, then we'll like push, what will be the uh, like maximum to reach this node. Suppose u, this is the max of this, or the this, like uh, the maximum weight we have crossed till now, or this, which is maximum, this will be here, like this is max of w comma capital W, okay? And what will be, like we are gonna pick all the batteries from this node, so this will be b plus b of v. And what will be the, like this is simply u, okay? So this is the simple extra, then we'll get the answer. Like the next time this will be, this v will be this node, and again there will be path, we'll go till like we reach this node, or like the priority queue become empty and we didn't reach that node, then the answer will be 0, minus 1, which is impossible, like this case, okay? So if we go through the code, like approach is clear, right? uh, if the approach is clear, let's see the implementation. Here, like input, then I create a adjacency list. This means I can, like I converted this to zero based indexing. So for let p node, I can go to p node if with this, like, or this edge is inserted here in the adjacency list. Then this is the priority queue. I have used pair int comma begin pair. Then like initially I have entered 0 0 0. Okay, this is not one, because this I converted all to like zero based indexing. uh, then uh, this is the dp, then like inserted all the things there. This is capital W basically, and this is capital B, okay? And there's same this part, and this is same, like this is I am checking, like the battery you have collected till now plus the battery you can collect from this node is greater than the number of battery, is greater than equal to the number of batteries required to cross this path. If this is true, then we are inserting the max value of this width plus the all the width we have crossed till now. With and the battery number of battery we have collected will be increased by uh, like is increased, like we have collected all the batteries at that node, and this will be the our like next the edges from edges to you. So this we are like inserting this into the priority queue, and like this will give the answer. Like this is basic the extra, like but the thing is we have to like usually in the extra where Like in this part, this is usually like b plus like weight, right? But here it will be the max, and like this is three value extra. So I hope this is clear. And if anyone has any doubt, if not, then uh, we'll end this post contest discussion. Thank you.
चलो फिर we are ending this post contest discussion of our code forces round 1026. Bye bye.